Now let's talk about what is called dereferencing a pointer. Dereferencing a pointer effectively means to read the thing that the pointer is pointing to. So if I was to dereference the pointer var7, I would be reading this value here, which is the thing that the pointer is pointing to. Okay? So this is basically what dereferencing is. Now, I gotta tell you here, actually, when you're writing a programming language, when you're creating your own programming language, you want to look into different symbols that you can use for different special operations in the programming language, the so-called operators. So when Dennis Ritchie was creating the C programming language, he had to find operators for doing things. Yeah, and he had to find symbols. So one of the symbols that he found was the star. And that star symbol is something that we use a lot with pointers. In fact, we use it for two different things. And it means two different things depending on circumstance. This might sound a bit confusing, but actually once you get used to it, it's fairly straightforward if I'm honest. So we use it for pointer declaration. And this is what the declaration of the pointer var7 looks like. Okay, we are also using it for pointer dereferencing. Dereferencing a pointer means reading the thing that the pointer is pointing to. And this is what dereferencing the same pointer would look like. So you can see pointer declaration looks like this and pointer dereferencing looks like this. The only thing that is difference between declaration and dereferencing is that in the declaration you have the data type in front. While in dereferencing, you don't have the data type effectively, you just have the name of the pointer. Yes, I had to find something to demonstrate my feelings about this, but actually it's not that bad. However, yeah, you could have chosen a different operator, we didn't. That's cool. So dereferencing a pointer means reading the thing that the pointer is pointing to. Now in this case, the pointer var7 is pointing to var3, and when I'm dereferencing the pointer var7, I am going to get whatever is inside var3, which is 0xFA. Okay, and that's all there is to it really. Now, as I said, yeah, if we dereference var7, we will effectively read var3. Let me show you how to do this in code now. So what I want to do is give you a very simple example right now and then dive into our slightly more difficult, slightly more involved example. So I'm going to run through one more example of pointers. This time we will see everything, including dereferencing a pointer. So let's create an integer. We will call it var0. And let's create an integer pointer. It's going to be an integer pointer, and I'm going to call it my PTR. So just a pointer. Then what we're going to do is say my PTR equals to the address of var0. So I'm taking the address of var0 and I'm putting it inside my PTR, so that this pointer is effectively pointing to var0, because inside the pointer I have the address of var0. And then what I'm going to do here, let me borrow one of the lines from our previous program. That looks like this, but instead of this, it's going to be var0. So just to report out to us, var0 contains something and lives in location something. Okay, and then we're just going to interrogate var0, not the pointer at all at this point. So let's interrogate var0. It contains 8. It just so happened to contain 8. We did not write 8 to it. We might as well write 11, which is going to be B in hexadecimal. 11 is B in hexadecimal. If I write 11 here, you will see it contains B, which is the hexadecimal equivalent of 11, effectively, and it lives in this location. Okay, that's cool. Nothing fancy here, okay? And then I'm going to say that my PTR contains something and it lives in location something, okay? And I'm going to change that to my PTR. So here I'm just doing the same thing as we did in the previous slide, effectively, in the previous chapter. So I want to see what is inside my PTR and where it lives. Simple stuff so far. Let's do that. So yeah, var0 contains B and lives in memory location this. My PTR contains this and lives in this memory location. So as you can see, my PTR contains the memory address of this, okay? And this is to be expected. This is what we were hoping the case would be, since we've put the address of var0 inside my PTR. That's cool so far. Now what if we wanted to read the thing that the pointer is pointing to? Effectively, what if we wanted to do dereferencing of the pointer? Well, all we would really have to do is say, first of all, let's do a nice printf statement. And what I'm going to write here is if we were to dereference my PTR, it would give us, and I'm going to print that as a %x, just print out as a hexadecimal. Doesn't really matter what you print it as, but I'm going to print that as a hexadecimal. So let's just dereference my PTR. Basically, this putting the star symbol here tells the computer to go to my PTR, read whatever the address of my PTR is, then go to that memory location that is pointed to by the address of my PTR, and then print whatever is found inside this memory address in the format of hexadecimal. In this case, I'm expecting to find B, because 11 is B in hexadecimal. And there you are. I'm finding that this is the case. B, which is 11 in hexadecimal. In fact, if I was to print that thing in decimal, so %d here and %d here, var0 in hexadecimal, in decimal, then I would get 11. So printing really the same thing, and you can see it's 11. Okay, so if I dereference my PTR, it points to var0, which contains the number 11 in decimal, and this is what we're getting. So this is dereferencing a pointer. I have now effectively dereferenced that pointer. Interestingly enough, it is possible. So basically, I have read this memory location using the pointer. Interestingly enough, it is possible to also read and to also, write to a memory location using the pointer. So here's what I'm going to do. I'm going to say dereference the pointer my PTR, and inside that place, so inside the place that my PTR is pointing to, I want you to write the number 15. And let's say that I wanted to just simply read this again. Okay, so I'm just reading it again. So in the beginning I expect it to be 11, and then after I do this step, I'm expecting that to become 15. And yes, as you can see, it was 11, and then it became 15. And if I was any more sensible, I'd put the I put a \n, a new line character here. Okay, and then, well, just made it to look a little bit better. Okay, now actually, if I was to read var0, once again, you will find that var0 has now changed. I accessed var0 indirectly using a pointer that points to its memory location, and I've written to it something indirectly. Yeah, using the pointer. However, since I have modified the contents of the original memory location, it means that when I read it with the var0 reference, when I read it as a var0, I will still be able to find that the contents have changed indeed. So let's run this, and you will see here that the contents have very much indeed changed. So it contains 15 now, instead of containing 11, which contained before. And of course you can see that I forgot again to put a new line here. So let's make it look nice and lovely. Yes, there you are. Okay, so I've modified, using the pointer, I have modified the contents of the original variable using the pointer, which was pointed to its memory location. So it is possible to use a pointer to read values and to write values from different pieces in memory. Now, if you understand this, you basically understood pointers. And in order to make sure that you understand this, I'm going to save this example, and I'm going to run you through the complicated example that we have seen on the slide as well, just so that we can reiterate the point. Now, coming back to our so-called complicated example, this is exactly what we had before, so I'm just going to run it so that you can see here. So var7 contains this value, which happens to be the memory address of var3. Okay, so now that we have seen this, and this is the same thing as we have seen in our previous chapters, what I want to do is I want to dereference that pointer. So what we're going to do here is printf, and within here what we're going to say is well, dereferencing var underscore 7 gives us, and then I'm going to print it as a hexadecimal, so %x, and then perhaps we want to give it, I don't know, maybe a new line at the end, a new line at the beginning, so it looks good, and then say okay, dereference var underscore 7. Because var7 is a pointer, it is possible to dereference it, and what we're going to see here is the result of this. So I'm expecting, since I'm printing as a hexadecimal, I'm expecting to see the contents or whatever is inside var3 effectively. Yeah, so FA, that's what I'm expecting to see on my screen. And here it is, dereferencing var7 gives us FA. So what we did is we created the number of variables. One of them is of the type integer pointer, the rest are just simple lovely integers. And what happened is we have var2 and we have var3, which has this contents and it lives in this memory address. var7, which is an integer pointer, has got the memory address, so inside that integer pointer we have got the memory address of var3. And then what we did here with this statement right here is we effectively dereferenced var7, which pointed us to var3, which has the contents of FA, 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 as you can see here, and you can see here. So we have actually indirectly accessed var7. Now, if we really wanted to do something fun here, we could say var7. So we dereference the pointer again, but in this case, instead of reading it, which is what we did here, we can write something into it. So I'm going to write 0x AA. So just to keep everything nice and hexadecimal, really. And then if I was to read it again, if I was to dereference the same pointer again, you will see that we have A inside it. And here is our proof. So we have A inside it. Now, the beautiful thing is, it is actually possible now to read var3. Remember, when we run this statement here, we actually changed whatever is inside var3, because the pointer var7 is pointing to the memory address of var3. Therefore, when we modified whatever the pointer is pointing to, we actually modified var3. So if I was to read var3 down here once again, I should find AA indeed. And here we go. You can see that var3 now contains AA, and it lives in this memory location, which is the original memory location of var3, which is this one, and it is the memory location that the pointer var7 is pointing to as well. So there you have it. We've modified, so we dereference the pointer to read whatever the pointer is pointing to. Then we dereference the pointer and we wrote inside the place that the pointer is pointing to a new piece of data, overwriting the previously written piece of data. And then we read it again from the pointer, using the pointer, dereferencing the pointer. We read it once again here in this statement in line 38. And then in line 40, what we did is we went and we read the original place using its original name, which is var3, and this still again yielded this result, because this thing is the value to which we modified the original memory location of var3 using the pointer. So that's why we got that. And there you have it. I've just tried to do it, I've just tried to dereference a pointer and read from it and write to it in many different ways in order to demonstrate the same point from many different angles, and I hope you now get it. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples, and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside.